As its name suggests, one-piece flow can be defined as an approach in which items move from one stage to the next stage of processing one piece at a time with no waiting time. It is therefore important to tell you about the benefits resulting from changing the process approach. Let's start now. I would like you to understand in detail these benefits so as to use the one-piece flow concept where possible after this lesson. The first noticeable benefit for you and your customer will be a reduction of the lead time. Example, your customer will be more satisfied as the order will be delivered faster. Is this really so? Let's check. In the example, you can see a production line comprised of 3 assembly workstations. Each has a cycle time of 1 minute. 3 types of products are manufactured in the production line. In your opinion, my cherished course participant, when will the customer obtain his or her first product? Let's move on to some calculations. As you can see, batch production flow is used here, so if you order, for example, a batch is 100 pieces, this means that each of the workstations needs 100 minutes to complete the whole batch. I have a question for you. How long will the customer have to wait for the first item to be produced from his/her process run? Let's assume that you produce components for your customer to be used on a car production line. So, what is the time? Yes, you're right. The first item will leave the production line after 201 minutes. The last piece of the entire order will be ready after 300 minutes. Therefore, the lead time is 300 minutes. In your opinion, what will your customer do if there is someone who will offer to supply an item much faster that is of equally good or better quality and is at a competitive or better than competitive price? I think we don't have to think about this too long. You will lose your customer. Yes, you've heard well. You will lose your customer. Let's see how the situation will look like if we change the production system in this factory. We will move from batch production flow to one-piece flow. We do not change the cycle times at the same workstations. In this system, parts are moved from workstation to workstation once the work is completed by a given operator. Look at the picture and the flow. Think about the lead time. Let's see how this is reflected in figures. The elimination of the production batch, that is, the quantity of stored semi-finished product between workstation, will certainly speed up the product flow. However, will the product flow be improved so much to significantly increase the customer satisfaction? We have 3 workstations, each with a cycle time of 1 minute. So what will be the total lead time without unnecessary inventory? Yes, you're right. This is so simple. The customer will be provided with the first item after 3 minutes, and the last product is in 102 minutes. Of course, this means, as before, that the entire order will be delivered to the customer within 102 minutes. To sum up, the use of the one-piece flow concept in this case results in a 3 times reduction of the lead time, as well as delivery of the product to the customer 67 times faster. I would like to remind you that we have just discussed only one benefit of using OPF system. Now, we will move on to further benefits. In this example, I will use the previously described production line, but as you can see, I have changed the interstation transshipment method. Now the product is moved from one workstation to another in containers holding 50 semi-finished items. By the way, I would like to ask you one thing. Do you know what the term is that is used for the inventory of semi-finished products? Have you already had a chance to learn about the 7 most important wastes? If not, I refer you to the course entitled Introduction to Lean Management. One of the 7 wastes is inventory, including the stock of semi-finished products, the so-called WIP, work in progress. Now I will show you why the inventory generated by traditional production flow, that is, without OPF system concept application is problematic. Below you can see an item that is processed by means of this production line. Now imagine that this is a steel plate with 5 holes of different diameters. The holes are numbered in accordance with the numbers of the workstations on which they are drilled. Hence, the first 2 holes are drilled at workstation 1, holes 2 at workstation number 2, and the last hole, 3, with the largest diameter, is drilled at workstation 3. Another thing you have to imagine is the processing machinery at each workstation. Each workstation is equipped with a numerical drill program to automatically drill the appropriate holes on each workstation. The operator's work is limited to loading and unloading the machine after the work cycle. It is possible that some unforeseen situation may occur during machine operation and product manufacture. Such a circumstance happened this time. At workstation 1, the machine cycle is completed using 2 drills as the holes have different diameters. Somehow the drill bit used to drill the smaller diameter hole has failed. The machine does not have sensors to detect a broken drill, so it continues its cycle, but this hole is not drilled. I will continue to stimulate your imagination. The operator is not used to having to check every plate, so he or she has not noticed the missing hole. If we take the inventory at workstations, the confusion and the lack of quality attitude among operators into consideration, what is the worst scenario in the case of a broken drill? I think you can see it. Indeed, in the worst situation at the end of the line, the quality controller will detect the defect, i.e. the plate without one hole, and order a selection. If we look at the picture, we can notice that at the end of the line there are 50 pieces. Between workstations 2 and 3, 100 pieces, and between workstations 1 and 2, 150 pieces. In total, the production line manufactured 300 defective items. That's not all. Someone will have to remedy the defect, so the company will pay for reprocessing. Of course, this is connected with generating additional incurred costs that the organization must accept. And what if the quality controller did not detect the fault and the defective batch of plates was sent to the customer? We will get a complaint and incur even higher costs. Should such scenario repeat, the customer will find another supplier. We have stopped here a little bit, but I would like you to understand exactly how such unfavorable situations crop up when following traditional flow processes. Now, I'll tell you what benefits you can gain if you change your approach. By connecting the workstations in accordance with one-piece flow practices, you will reduce the space required and you will get rid of the inventory. The product will be moved from station to station automatically. If you add appropriate operator attitudes towards quality, you will get short lead time and no quality risk related to overstocking. Now, let's move on to the subsequent benefits resulting from line balance. In the picture, showing workstation inventory, different quantities of stocks are evident. What does this situation tell us? Yes, it indicates uneven workload at the individual workstations. So, balancing is necessary in order to level out this workload. Otherwise, an inventory of semi-finished products may continue to form between workstations, or operators will be waiting for each other to complete their sub-processing. By eliminating the time loss and waste caused by uneven workloads, we become more flexible and we may be able to produce greater numbers of pieces in a shorter time interval. We and our customer will certainly be satisfied with this situation. Another benefit is improved workstation ergonomics. Some implementations of one-piece flow require operators to move together with the product between workstations in the flow direction, performing all necessary operation along the way. I can assure you that hardly anyone will like it at first. They will even be hostile. if they see that they have to operate several machines. You may hear such comments as, "How is this possible? You just want us to do more at the same wage." However, on talking to the same people after a few months of working in the new mode, you will find that nobody wants to return to batch production flow. Why is it so? This results from elimination of routine. Operators, through continuously changing their positions, do not feel the effects of repetitive movement. Their one movement routine no longer exists. This affects the mood and relieves the body.